Good day, engineers. Para sa video natin ngayon, ang i-discuss natin is yung continuation of the lateral earth pressure distribution para sa braced cuts. So, previously or on our previous video, ang diniscuss natin is yung cuts on sands. Ngayon, we will discuss braced cuts on saturated clay. So, si Peck, hinati niya yung uh, cuts in saturated clay into two. So, sabi niya doon, meron daw tayong stiff fissured clay, tapos pwede rin daw itong maging soft to medium clay. Pero paano natin malalaman if stiff fissured clay or soft to medium clay yung saturated clay natin? So, dun papasok yung tinatawag natin na factor, which is N sub S, and this is known as the stability number. So, using this one, madedetermine na natin if we will solve a stiff fissured clay or a soft to medium clay. So, punta tayo on the part of the stiff fissured clay. Sa stiff fissured clay, sabi natin doon, kailangan natin ng stability number which is N sub S. And the formula for that stability number is equivalent to gamma H over C. So, para ma-determine natin or para maging stiff fissured clay yung sinosolve nating soil on the braced cuts, so dapat daw ang stability number should be lesser than or equal to 4. So, pag lesser than or equal to 4, yung stiff fissured clay natin, yung sinosolve nating soil or clay, that is a stiff fissured clay. Then, ang diagram na gagamitin natin for a stiff fissured clay is the one shown here. So, meron siyang combination, ito siya, meron siyang combination ng uniformly varying loads. So, dalawang uniformly varying loads on its two sides. At meron ding uniformly distributed load on the middle. So, yung uniformly varying loads on the two sides, syempre makukuha natin kung hanggang saan siya dun sa sheet pile natin or dun sa braced cuts natin by having 25% of the total height. So, yung total height naman natin is kung ano yung height nung sinusupport na cut. So, ito yun. So, kung ano yung height niyan, yan naman yung kinukuha natin for that trench or braced cuts. Then, 25% nun for both sides, yan yung uniformly varying load. And, syempre, since 50% na lang yung natitira, the 50% height or the 50% of the height is para dun sa uniformly distributed load. Then, same procedure as before from the deep cuts in sand. So, syempre, meron ka ditong reaction loads coming from the struts. So, lahat ng nasa gitna na struts will give you a hinge support. So, para kapag statics, or pwede natin siyang isolve using statics kasi that is a statically determinate na structural member. So, ngayon, paano naman natin kukunin yung pressure or yung height ng pressure diagram? So, yung pressure or the height of the pressure diagram will just be equivalent to a value P sub A is equal to 0.3 gamma H. So, since 0.3 gamma H siya, that is 30% of the vertical stress. Kasi alam natin sa soil mechanics, yung ganitong etong part na to is yan yung vertical stress natin sa soil mechanics. So, yung P sub A for a stiff fissured clay is just 30% of the vertical stress. So, yun ngayon yung pressure or yung height ng pressure diagram natin. So, that will be for the part of the stiff fissured clay. Now, let's proceed on the soft to medium clay. Sa soft to medium clay, so this is soft to medium. Sa soft to medium clay natin, syempre, kukumputin mo pa rin yung stability number as it is. So, that is NS is equal to gamma H over C. So, the stability number should be greater than 4. So, sa soft to medium clay, kailangan ng stability number natin na nako-compute will be greater than 4 para ma-under siya ng soft to medium clay. Then, the diagram for a soft to medium clay will be this one shown here. So, it just consists of isang uniformly varying load dun sa upper side, then the rest is a uniformly distributed load. And same as sa stiff fissured clay, yung length kung saan makakatanggap or yung height na makakatanggap ng uniformly varying load is still 25% of the total height, and the rest is uniformly distributed. So, ibig sabihin, yung 75% na natitira sa total height natin will get a uniformly distributed load. Then, on the part of the pressure na tatanggapin or yung pressure load natin, that will be P sub A is equal to gamma H minus 4C. Or, P sub A is equal to 0.3 gamma H. And since this is a design problem, so syempre, ang kukunin natin between the two is whichever is the larger or the greater value. So this is whichever is greater. So, yan ngayon yung pressures natin and yung pressure diagram natin for a soft to medium clay. At yan na rin ngayon yung dalawang diagrams natin for the cuts and saturated clay. Ngayon, syempre, on-site, hindi naman laging saturated clay lang or clay lang mismo yung soil. may chances na that is a combination of two different types of clays, or may pagkakataon na stratified yung soil. Ibig sabihin, may part na sand, may part na clay. So, let's proceed dun sa pag yung cuts natin is layered clay na may magkaibang properties. So, from the figure shown, syempre, meron tayong two types or two different clays or layered clay na may magkaibang property. So, ito yung clay number 1. And this is clay number 2. So, for clay number 1, si clay number 1, syempre may sarili yung unit weight which is gamma 1. Meron niyang angle of internal friction, phi sub 1, and may sarili yung cohesion. So, that is C sub 1. Then, this is clay number 2. So, meron siyang sariling unit weight which is gamma sub 2. Meron siyang sariling angle of internal friction, phi sub 2. And meron siyang sariling cohesion which is C sub 2. Then, so, si clay 1 may height 1 and si clay 2 may height number 2. So, getting the total height, we can have a height h. So, ngayon, paano natin siya isosolve kung dalawang or kahit maraming layers na siya ng clay? So, kung layers lang siya ng clay, ang gagawin lang natin is parang Varignon's theorem. So, para sa Varignon's theorem natin, we can have yung bago nating unit weight. So, this is just for the unit weight nung soil natin. So, we can have unit weight of the two soils as gamma bar times the total height is equal to, so, that is gamma 1, yung unit weight nung first clay or clay number 1, then height niya, which is h1, plus gamma 2, or unit weight number 2, nung clay number 2 natin, and yung height nung clay number 2 natin. So, from this one, we can get the unit weight nung or the modified unit weight nung dalawang clays natin, which is gamma bar. So, that will be equivalent to 1 over h times gamma 1 h1 plus gamma 2 h2. So, kahit tatlong layers pa yung soil natin, basta clay siya, we can have iisa lang na unit weight na para lang tayong nagbabarignon's theorem. So, that is gamma bar is equal to 1 over h times gamma 1 h1 plus gamma 2 h2. So, ngayon, ang isa pang required kasi natin to determine the pressure and the strut loads is yung C bar. C bar stands for yung cohesion or the modified cohesions nung dalawang clay. So, to get this one, syempre, same principle, Varignon's theorem din. So, that is C bar times H is equal to C1 H1 plus C2 H2. Then, arranging the term, we can have a modified cohesion which is C bar. So, that is 1 over H times C1 H1 plus C2 H2. After getting these two modified unit weight and modified cohesion, you can now proceed in getting the stability number. So, gagamitin na natin yung procedure for the cuts in saturated clays. So, you will get the stability number. Titignan mo kung papasok siya dun sa stiff fissured clay, which is ang stability number is lesser than or equal to 4, or kung papasok siya dun sa soft to medium clay, which is ang stability number is greater than the value 4. So, after getting the modified cohesion and the unit weight, babalik ka dun sa procedure for determining if that is a soft to medium or a stiff fissured clay. So, yan yung procedure natin for cuts in layered clay na merong different properties. Now, paano naman kung stratified yung soil? Ibig sabihin, may part sand, may part na clay. So, for cuts in stratified soil, eto siya. So, sa cuts in stratified soils, so, from this figure shown, meron tayong sand sa ibabaw. Ino-overlay niya yung clay na nasa ilalim. Then, yung sand natin, meron niyang unit weight which is gamma 1. Meron rin niyang sariling angle of internal friction which is phi sub 1. The difference is such that yung part natin ng sand is cohesionless. Next is sa clay, meron tayo syempre unit weight ng clay, angle of internal friction ng clay, syempre meron niyang cohesion, and meron niyang eta. So, si eta dyan, yung parang N na nakaganyan, si eta is the coefficient of progressive failure. So, iba-iba to. And this is varying depending on the problem. Ang values nito is ranging from 0.5 to 1.0. And sabi dito, kapag Chicago clay siya, that is ranging from 0.75 to 1.0. So, yan ngayon yung eta, which is the coefficient of progressive failure. As you can see, dito sa parts ng stratified soil, hindi natin pwedeng gawin yung part ng Varignon's theorem. Ang kailangan natin gawin dito is dun sa part ng cohesion or yung cohesion niya is meron tayong sariling equation na dapat nating gamitin. So, pero before that, we must proceed in getting the unit weight. So, sa unit weight naman walang problema. Pwede pa rin natin gamitin yung Varignon's theorem doon, which is gamma bar H is equal to gamma 1 H1 plus gamma 2 H2. Then, syempre, gamma bar still is 1 over H times gamma 1 H1 plus gamma 2 H2. So, wala tayong problema on getting the modified unit weight. So, sa cohesion tayo magkakaproblema since hindi natin pwedeng gawin yung Varignon's theorem at hindi natin pwedeng iset yung sand as a cohesion na equivalent sa 0. So, for this part, kakailanganin natin yung tinatawag natin na QU bar, which is yan yung unconfined compression strength. And since meron siyang bar dun sa taas, this is modified. So, alam natin yung unconfined compression strength na yan. Yan yung galing dun sa unconfined compression test natin from the shear strength test. So, alam natin that dito natin makukuha yung cohesion. So, magkakaroon tayo ng CU bar dyan, which is, sabi natin, that is 1/2 of the unconfined compression strength. Kasi that is QU bar over 2. Kasi alam natin from unconfined compression test na kapag nag-test tayo ng certain soil like clay, meron niyang lalabas na circle or more column failure diagram na from 0, gaganon siya. Tapos, this is sigma 1. Si sigma 1, that will correspond to the unconfined compression strength nung clay natin. Kasi, since that is compression alone, wala naman yang initial stress or yung sigma 3 natin. So, ang compression strength lang niya or yung tanging compression na tinatanggap niya is galing doon sa delta sigma or yung load na idinagdag natin, which is also sigma 1 siya kapag unconfined compression strength. And alam natin na kapag sigma 1 yan or that is also delta sigma, kapag kinuha natin yung radius niyan, that will correspond to, for unconfined compression strength, that will be Cu. Kasi that is delta sigma over 2. So, ito na mismo yung cohesion nung soil natin. So, for this part of the stratified soil, ang equation na gagamitin natin is para makuha yung Cu bar, that will be equivalent to 1 over H times, so this is for the sand muna, that is gamma 1 H1 squared. K is tangent of phi 1 is equal plus H2 eta Qu. So dito, as you can see, kung mapapansin nyo, wala din pa yung part ng cohesion nung clay. Ang gamit natin is unconfined compression strength nung clay mismo. So, ibig sabihin, dadaan pa muna tayo ng unconfined compression test bago natin ma-determine yung modified na unconfined compression strength nung dalawang soil natin. And gagamitin natin itong formula na to. So, ngayon, ang hindi lang natin alam dyan, what is Ks? Kasi alam natin na yung eta, alam na natin yung Qu. So, iba si Qu bar kay Qu. Si Qu, yan yung unconfined compression strength lang ng clay. Then, ang wala lang dyan is yung Ks. Si Ks, as a designer, tinitake natin to as 1.0 for design purposes. And this is corresponding to the hydrostatic pressure ratio for sand layer. So, lagi naman siyang 1.0 since this is a design purpose problem. Unless otherwise stated sa problem, ano yung gagamitin mong K sub S or Ks. So, after getting yung Qu bar, syempre Qu bar pa lang yan. That is unconfined compression strength. So, ngayon, after getting this one, syempre, kailangan natin maging cohesion siya. So, babalik ulit siya into Qu bar over 2 para maging unconfined cohesion siya. So, after getting yung modified unit weight, which is same, Varignon's theorem, and after getting Cu bar or the unconfined cohesion, which is Qu bar over 2, so we can now proceed ulit dun sa pagkuha nung, kasi parang natin siyang na-convert into soil na clay lang. So, using the gamma bar and the Cu bar, pwede na natin siyang gamitin dito sa cuts in saturated clay. Kailangan lang natin siyang i-determine if yung stability number niya is lesser than or equal to 4 para maging stiff fissured clay siya. And if the stability number is greater than 4, syempre soft to medium clay natin siya isosolve. So, depending on what type of saturated clay siya, so yun din yung type ng diagram na kung paano natin siya isosolve. So, that will be all for the concept of the lateral earth distribution on braced cuts. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.